Okay, so I'm going to do a history talk, sort of, which is based on some work I did with Sander, got my head back into thinking about file staging in Parsl a little bit and digging up some of the history. So this is not about that work, but it's going to be about the history of file staging in Parsl and how we got to what we have now and what might or might not happen in the future. So here's a tutorial that apparently I did at the TerraGrid conference in 2006. And this is a tutorial on the virtual data system, which you can imagine is Parsl version -2. Before Parsl, there was Swift. Before Swift, there was the virtual data system. And this is one of the diagrams about what running a workflow on the grid looked like theoretically in 2006. And a lot of this, if you changed the names and freshened up the graphics a bit, it would look very much like how you might describe some idealized multi-site run in modern times as well. So we've got my cursor here. Yeah, I've got my cursor. There's a workflow description in some language. In Parsl, we use Python to describe that. Oops. In VDS, there was its own slightly awkward language called the virtual data language. We've got a submission sites. Some user submits their workflow here. Lots of internal components to make it seem nice and complicated. And then tasks from there go to these remote sites. And there's stuff over here that will run stuff and send the results back. So the reason I wanted to show this diagram is because I feel like a lot of file staging work only makes sense in a bigger context. So something like this that is projecting, that is an application would look like this. Otherwise, you have these file staging features, and it's a bit weird to understand why do we do this? Why is this here? Does this still make sense? Things like that. So this is sort of a motivating application that I found in that slideshow. The link to the whole slideshow, if you want to see what the 20 years ago generation of this group was up to, you can have a read through that presentation there.
So Ben, I wonder, when in your arrows that show Globus, I wonder which was this Globus version minus something?
This would have been Globus version 2.
Okay.
And I will come to the specific technologies in there in a bit. But yeah, GT2. So virtual data system was from around, say, 2000 to 2006. And then 2006, it started moving on to Swift and Pegasus, the two successor projects. So there's a vocabulary thing. I'm going to be talking about file staging here, so not data staging in general. So when I say files, I mean, I'm not going to really strictly define them, but I'm going to say it's maybe a thing, it's got a name, and it's this opaque sequence of bytes. Right? And file staging is the act of getting one of those files from where it lives in some kind of storage elsewhere to where the work is going to be done. Your worker code, and where the worker code can open that file with an operating system open call, as if it was a local file, and back again when you're finished. So the contrast there, files versus data in general. In Parsl, the big other thing we move as data is Python objects that you pass as parameters. And that doesn't look at all like file staging. We've got serialization. We pass it through the same control channels that's just as part of the general task submission. There's all kinds of fun that we all enjoy when we try and treat Python objects as opaque sequences of bytes and try and take those opaque sequences of bytes and turn them back into Python objects, because they're clearly not the same thing. And another example I saw recently was, well, my worker nodes need to make an outbound TCP connection to some experiment server. That's also data in some sense for your task, but it's not either a Python object or a sequence of bytes. So that's just to say a lot of the time people will talk about data staging and we have data futures and things like that. Whatever, we're talking about files, not this other stuff. So here's I chopped up a bunch of slides from that same tutorial, and this is an example workflow from 2006. So what this looks like on the left is this is the workflow that a user might describe to the virtual data system. And it takes the form of files. It's really file driven. These parallel lines represent files. So the end output is called f.out, the output file. And then you also describe to virtual data system to construct this file, here's a task that you can run. So it's a little bit more like make almost, or that style of build system where you describe the output and then we work all the way back, and eventually we might want to do something with the input file to get all the way there. And when you run the virtual data system, when you run this, it fiddles with the graph. We've got 1, 2, 3, 4, 5, 6 slides of VDS fiddling with the graph to give you this workflow on the right, which is something that's easier to execute. So the first thing you'll see is that these B and C nodes have disappeared completely. And what's happened there is VDS has a interface to what a Globus component that used to exist, probably doesn't anymore, called the replica location system. And in this hypothetical case, the replica location system said, well, f.d already existed. We don't need to run those tasks. Instead, we can replace those tasks with this, which is a file staging, a file transfer. So I know FD exists somewhere else. I'm just going to copy it into place instead of running compute. And the assumption here is basically it's cheaper to do that file transfer than it is to perform the compute, which is not always true, but that's the assumption in this graph. What else has happened? Well, we've got these tasks that we've got left over. These two have been assigned to a site A, this sort of vomit color. And these two tasks have been assigned to run on site B, this sort of brown color. We've now got these other staging jobs that have been added in. So to run on site A, it needs the input file. So we've got to stage it in from somewhere. That SI means stage it in. When we've made the result here, we're going to stage it out somewhere. So that's what this darker green stage out is. But in between task C, which is going to create file C on site A, we now need to move it to site B so that task E can read it as input. So there's a sort of it's labeled as a stage out here, but I would call it some kind of trans staging kind of task. And then a bit of administration, 2 tasks that are going to create the working directories on site A and site B. All the tasks on those depend there. And at the end, we're going to register the result with the replica catalog so the next user can find it. So that's sort of how VDS worked with a lot of this idea of sort of graph rewriting. Was how a lot of this was modeled. So what's a site in that context? I talked about there being site A and site B, and here's the graph fragment of what a site is. So it's somewhere where we can run tasks in GT2 days. In the time of this tutorial, that was a Globus component called GRAM, the Globus Resource Allocation Manager, something like that. I can't remember exactly. But sort of you could imagine that's where something like Globus Compute would fit in more modern times. We've got some kind of shared storage where all the tasks are going to be able to access files. So that's usually a shared file system. It doesn't always have to be, but basically it is almost always. And somewhere you can transfer files in and out. to that shared space, which is Grid FTP in the GT2 days. Something like Globus Connect would fill that same role in more modern times. So a site you can sort of imagine as a supercomputer at an HPC center, which has had the whole Globus stack installed on it. Okay, what does that look like in modern Parsl? That, what I've just shown, is what it looked like in 2006. Parsl, or some parts of Parsl, the intention was to see what this would look like if we made it all expressible in Python. So here's some code fragments. We're going to define a little workflow which is going to sort some strings. So we're going to pass as an input an unsorted file, and the outputs are going to go into the sorted file. And we're going to define up here an unsorted file lives on this Globus endpoint, and the sorted file also will eventually, when it's made, live on this Globus endpoint at these paths. Okay, we declare those, we make this invocation of a Python app, and then we say, all right, now we're going to wait for the result. We've also got to tell Parsl how to do something with those Globus URLs. So you would need to be logged in, and then you also have to say, on my compute site, this is the Globus endpoint for the compute site. This is where it's going to end up putting files. And then when you've declared that Globus staging, you feed it into the appropriate place in your Parsl config. Then you run that, and it all magically works. So what you end up with is similar to the graphs I showed before. It'll stick a Globus transfer staging task in there. Then it'll run the real task. Then it will put a stage out Globus task in there. And inside the app, this is the implementation of sort strings. You can see there's no remote file access at all. We just do a normal Python open of whatever path we've been passed here. And we don't care what that path is. And when we write the output, again, we write it to this path that we've been told to write it to without caring where that is. And we rely on the staging system to put the file in the right place and take it away again at the end. So everything inside your task looks like local file system access. So although we are trying to make everything look like local file system access, sort of, it's a non-goal to make some global distributed POSIX file system. Okay, there are input files, they're read-only. If you screw around with them and make changes, maybe you're going to mess up caches, maybe your results will be visible to, your changes will be visible to other tasks, maybe not. That's just, don't do that, right? That's out of scope of what you're allowed to do. And the same with output files, you can only write them out once. You can't update them, you can't append stuff, whatever. So these are very tight semantics on what you're allowed to do to your input and output files. So one example use case is, say you're running 10 apps and they all want to share an SQLite3 database. You can do that in Parsl if you want, that's not forbidden, but the Parsl file staging stuff is not going to help you manage that SQLite3 database file. So there's a little gallery of the providers that are implemented. So some of them don't need any configuration and they're there by default. There's a no-op file staging, says it looks like this file is on a shared file system. I don't need to do any staging. There's FTP and HTTP staging that knows how to download FTP and HTTP URLs. There's zip file staging, which I'll come to later. The ones that need config are Globus and rsync. Generally, they need to be told some kind of security credential and some kind of description of what your file system looks like when you're accessing it through that protocol. And then we've got a couple of other implementations of HTTP as well, which I'll come to now. So there's a distinction between the file object, which describes where the file lives or what the file is. It doesn't tell you how to get that file. And then these staging providers describe how to get a file. So I just showed you two different implementations for HTTP. There's the separate task stager by default, which generates a new Parsl level task for every staging thing. And that task goes into the task graph and can be scheduled separately from the actual workload, for better or worse. There's an in-task stager, which annotates, it replaces your task with a little shim layer that does the staging inside your task before your real code runs. The task find executor knows natively how to stage in HTTP files. So if you're using that, you can say, don't do any HTTP staging, just pass that straight through to taskfind and let taskfind deal with it. I did a demo in Parsl Fest 2019, how to implement HTTP with a cache. So in that case, there isn't even an HTTP get happening if there's a cache retrieval, despite the URL. Other sort of made up hypothetical stuff would be sometimes you could find fuse file systems which expose all of HTTP to as a fuse file system. So in that case, you would make your staging provider say, go open this special magic path, and that's where you'll get your file. Or maybe you wanted to do something with the more recent HTTP protocol with a more recent library. You'd be able to swap that in without having to change all your file descriptions. So if you wanted to make a new staging provider, here's the lol provider. It's going to look for URLs like lol//cats. You make an instance of this staging abstract class and you configure it into Parsl. And for every file that Parsl comes across when you run a task, it's going to ask your provider, can you stage this file in? And you get given the file object. And in this case, we're going to do something quite simple. We're going to say, is it a lol URL scheme? And if so, we're going to say, yes, we can stage this. And then Parsl will call back to you in two different ways. One, it will give you a chance to this. These signatures are quite horrible, but it will give you a chance to launch new Parsl tasks to do that staging and add them in as dependencies. And it will also let you completely substitute the code of the task to be executed, the Python code, with your own replacement Python code, which usually you would say, I'm going to run your code, but before that, I'm going to run my own staging code, or after that, I'm going to run my own staging code as a wrapper, which is quite a common pattern in Parsl to do that code replacement with wrappers. Okay, so a couple of use cases that don't look like that multi-site use case. Colin presented a month ago on some stuff with Taskvine where they've been looking at using files and Taskvine's file management to avoid the shared file system. So he had a shared file system run of, I think, Parsl doc. It was taking 1,000 seconds. And he worked on first getting Taskvine to move those files around instead of using the shared file system to move those files, and got down to 300 seconds removed. And then he did another thing, which is a bit more complicated, which is expressed which of those files could be thrown away at the end of the run and didn't need to go onto the shared file system ever. And that shaved another 100 seconds off. So this is a pretty stark example of sort of performance related stuff within a site of avoiding the shared file system, even though it's there, and how Parsl can help you do that. The other non-site use case was Sander in Kent wanted to store standard out and standard error into a zip file automatically as his tasks finished. And that led to quite a bit of work with 3 new features in Parsl. So there's the zip staging provider. Parsl then learned to treat standard out and standard error as stageable files, which it didn't used to be able to do, and some technical work with URLs. So now you can specify a URL like this as an output file. And when Parsl stages out into that URL, it doesn't do any network transfer. It runs zip basically to zip up your file from your workspace into that zip file. So that's sort of reminiscent. That's a that's not touching the internet at all. And it reminds me a little bit of a use case we had 20 years ago, which was with tape robots. So these are all tapes. There's a big robot arm. When you request a file from the tape robot, it goes and finds the tape with your file on it, loads the tape into a tape drive, and stages it in. And that's a sort of archival activity which takes a moderate amount of time. You wouldn't expect to do a POSIX file open on that sort of file. It needs a more explicit action to get it. So people don't use file staging very much in Parsl, despite those two use cases. I have some thoughts on why, which I'll say here. These are quite opinionated, a little bit opinionated rather than technical. So the first one is that Parsl's got all these different computation models it supports. So VDS was very much file-mediated workflows. They're DAGs of files with tasks, and all the tasks do is consume files and produce more files. There are no other effects. So you can express that in Parsl. But Parsl also has these Python-oriented workflows. So if I had a thing for counting words, I would expect to perhaps, here's an app for counting words. I would expect to maybe feed in a string and receive an int at the Python level. That it wouldn't be a transformation from a file to a file. It would be a transformation from a Python data type to another data type. We also have collections of tasks with unknown to Parsl side effects. So I can express run task A, run task B after task A is finished. I'm not going to tell you why that order exists. I just want you to run them in that order. So that might be an external data store. So that SQLite 3 stuff I was talking about earlier, Desk, for example, stores their own shared registry of data files. So Parsl needs to know the order of doing the science computations, but it doesn't need to touch that data store. Or we've got collections of tasks where Parsl doesn't even know the dependencies. So Logan, for example, has this dynamic steering code. It chooses what tasks to run, when to run them for basically science reasons. So that doesn't even look at all like a DAG, even though there are these dependencies in there. And all of these three, then they're not really file oriented. So they don't really need files. They're very much more living in the Python world. And if they don't need files, they don't need file staging. Multi-site is too hard for the payoff, right? So implicit in a lot of that stuff in the first graph was that you would want to run on 2 sites, which is quite hard. Software installation 20 years ago was really hard to get done right and incredibly manual. It looks a lot better in modern times with containers and Conda and things like that. Task execution is also hard. Parsl channels was Parsl's first attempt to do that, and it doesn't work very well. Globus Compute does a better job, but that's an ongoing project, right? And there's also this question, why would you run K tasks on 2 sites? Why don't I just run 2K tasks on 1 site? Like, why would I split across 2 sites? And unless you're filling, I mean, there are reasons, right? But to be the devil's advocate, unless you're filling an entire supercomputer, there's no reason to use a second supercomputer. Okay, and then when you're only on 1 site, well, I can just run everything on the login node, right? I don't need any of this remote execution. Just run it all on the login node. So the gradient there pushes you towards not using file staging either. And the third thing I think is going on is when you build your app at small scale or medium scale, you start using a shared file system and then you architect your app accidentally without thinking about it so that it requires this random access to your data store. It's very compelling. My supercomputer looks just like my laptop is what I wrote here. It's very hard to re-architect later. You just kind of accept without even thinking about it that there's this invisible, unavoidable file system performance penalty. And that's just naturally what people will do. If they're coming from their laptop, they will use the bits of a supercomputer that look like their laptop. I think in more recent times, there's a lot more cloud stuff where you don't have shared file systems. It's much more common these days for people to run a container which doesn't have a shared file system with all the other containers they're running nearby. So I think now it's easier to make an argument for not doing shared file systems. But still, that's the natural direction of the scientific programmer is to do that. And I've got a few dirty secrets that I'll just go through quite fast. Our implementation of staging is very inefficient. The tasks look like a Parsl job, which they block a worker, running the transfer, doing the synchronous transfer. I think given the experience we've had recently with integrating with other systems with futures, it would be probably quite straightforward dev work to say, all right, we're going to have one thread, manages all the Globus transfers, interfaces back into core Parsl with futures. I think that's very doable if someone wanted to do it. The API kind of looks ugly. We have this file class which changes in meaning in different places in the code base. I think that dev work could just separate that a bit more. I don't think that file class needs to be URL based. It just needs to be a class that staging providers can understand. And if you're a staging provider and you don't understand this weird subclass of file, that means you probably don't know how to stage it. So we don't need everyone to be able to read URLs. There's this really ugly output syntax as well. You've got to pass. It's essentially pass by reference. You need to know your files ahead of time and say, I would like to have these outputs staged out and here's where they are. It's sort of forced that way by the way that our staging model works, which is inherited from VDS that assumes that you would be able to describe everything ahead of time. Sometimes people want to, who is writing to me? Yeah, I do. Yeah.
Sorry, I was muted. I was just pointing out that there are good reasons why we might want to move staging off of the workers.
There's good reasons for all of this, right? But whatever. Yeah, that's ugly. What's next? Oh yeah, temporary files. These are weird. Say I have two tasks running on a site A and I've named a file to be stored as Globus whatever. What we'll get now is we'll run the task, we'll stage it out to some Globus endpoint, we'll stage it back in for the next task and then run the next task. It would be much nicer if we didn't do that. If we ran the task, we want to stage it out to keep forever, but we can also straight away run the next task. We don't need to stage it in again, and we don't need to wait for that stage out to happen. That is just, yeah. If we have some intermediate file that's going to be moved between site A and site B, at the moment, again, we don't have a sort of trans staging concept. We only have the concept of staging it out after this job somewhere and staging it back in again from some persistent space over here that isn't represented for the next job. It would be much nicer if we could have just a transfer job between the two sites, in addition to perhaps the permanent stage out job. And if you're running on a shared file system or whatever, say you have no staging at all, here's a file that comes out of this task, it's going to be used by this task. When is it safe to delete this file? That seems like if I'm just giving you a simple graph like this, I think it's pretty straightforward to say I will delete it after the second task. But in this very dynamic Python environment that we have in Parsl, what if I now launch another task later on that tries to use that file as an input? And Parsl said, well, we deleted it. So in fact, we never delete anything. But for some workloads, you have to delete stuff as you go along because you don't have the scratch base for it. That's why you're storing your stuff elsewhere. So when's a task finished? Is your task finished when the work is done, or is it finished when the stage out is done? Well, depends what you want. Do you want to use the Python results? It's finished there. Or do you want to use, do you want to know that the output files have been stored securely somewhere? In which case the notion of finished is here. So there's a bit of a subtle notion of what a task being finished means that is not very clear in current Parsl. What's this one? Oh, standard out. So we used to have bash apps. You can have standard out and standard error directed places, and you can stage them out as files now, but only in the last week or so. Before that, that's the work that got me onto thinking about this talk. Earlier, before that, it has this weird mode where you can say, actually go and append to this file that already exists on the file system. So if you wanted to run 3 tasks in a row, you could have them all go to the same standard out. That's like this rival file access model, which doesn't look at all like the staging I talked about earlier. It's doing forbidden things like append. There's no concurrency protection, whatever. So I don't really like that, but here it is. And then this one, file staging versus checkpointing. I'm not even going to read through this. This is just a brain explosion of questions about what does file staging versus checkpointing mean, which is very interesting. But so it might turn out that file staging isn't special in any way. We've done work recently with Andrew Rosen on having rich object dependencies. How do we depend on a thing that isn't a future, which is a little bit like stage in. Here's a file object. We want to depend on it, but it's not a future. In Andrew's case, it's things like lists of futures or a list with a dict with a future buried deep inside. And more recently, this notion of sub-workflows and join apps has become legitimate, or just has come into existence. And it's pretty legit. People are calling into Globus Compute using join apps, for example. So maybe when you think about staging, you can think of it more in context of sub workflows like this. And then things like proxy store. Is proxy store transferring files? Is it doing file staging, or is it transferring Python object? Do we even care, right? What the answer is at a Parsl level? And probably not. And this is pretty clearly not core functionality anymore. In VDS, it really was, moving those files around really was a core part of what VDS was doing. In our modern use cases, our users are quite happy for the most part, not doing anything with staging at all. So possibly we shouldn't be having file staging so tied into the core of Parsl anymore. And maybe we should be trying to generalize that a little bit to things like workflows and task elaboration in general. Maybe that's an interesting sort of research and development direction. So at the end, Parsl's history is rooted in file-driven workflows, but it's evolved way beyond that. All of this file staging stuff really only makes sense when you're in this broad context, in a broader context of, with multi-sites, you have to have stuff like software installation solved as a problem, or remote execution as a problem solved. It doesn't make sense for us to be saying, look, you can stage files. By the way, your tasks won't run on the remote system. So, haha, right? That's not a thing we can say to our users. And then when you're looking at things for performance, that's a thing that really people only start thinking about when it's too late to be re-architecting their application. And maybe that needs a bit of user direction when you're doing application consulting. And definitely some of the HPC admins will love you for that. I've sat in a taxi with some HPC people, and they've said, we keep telling our users not to use the shared file system, but they still do, because it's there, right? So maybe if you wanted to start thinking in these directions when you're talking to users, you need to think about this a little bit earlier on. So yeah, it's good stuff. doesn't always make sense. There's a lot of development it needs. It's very rough, but that's what's there. And hopefully some of that historical context helps understand why it looks like that and what you might encounter if you started doing this yourself. Okay, the end.